and then I just upload these to YouTube. That way, if you ever need them, okay? All right, guys. So this, I believe, it was. I forgot what part it is, but let's just start over because on my notes, this is still notes 1-1, but specifically we're gonna cover difference of squares. So, real quick, so difference refers to minus, okay, so we're talking subtract, minus. And then squares, we're not talking about the shape of squares, we're talking about something called perfect squares. So that would be the better name, right? The better name would be the subtraction of perfect squares. And we're actually factoring is what we're doing. This is a form of factoring. You've done it before, okay? But I'm gonna try to help you understand it a little bit deeper. So before we continue, I need you to understand what is a perfect square. A perfect square. Okay, I'm gonna abbreviate PS now. Perfect square. What is a perfect square? Just to say that. So what do we mean when we say perfect square? Okay, so perfect square is very simple. Is if you take any number, any whole number, and you square it. Okay, and I want you to make this list so that you have it. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. You can probably make it just keep going down, but so you can see the whole teeth, like all the numbers at once, and we'll go to the side. But you could probably just keep on going. Okay, 1 squared. Now, squared, all squared means is times itself, right? So, for example, 1 squared simply means 1 times 1. And let's do it together. Let's try not to use our calculator yet. Okay, so what's 1 times 1? 1. Okay, let's make this list together. 2 times 2? 4. Probably right now a lot of people are answering. We're going to get to a point where only like one person will be answering. Watch. 3 times 3? 9. 4 times 4? 16. 5 times 5? 25. 6 times 6? 36. 7 times 7? 49. We lost some people on the 7s. 8 times 8? 64. 9 times 9? 81. 10 times 10? Our favorite. Okay, this is what I need you to know for sure. Okay, like I know you have a calculator and you can plug it in, but I want you to kind of keep an eye out for these. If you receive those numbers, they should stick out to you, okay, because they're special numbers called perfect squares. But just for fun, let's keep on going. Okay, let's see how far we can get as a class. What's next? 11 squared? 121. Anybody know 12 squared? 124. Anybody in this classroom know 13 squared? That's usually where it drops off. But I've had some. I'll tell you that one because it's kind of easy to remember. 169. But you know what's interesting? In another class, like I have it in the morning, I have a gentleman that sits right here. He's a foreign exchange student from Germany. I just got him like 2 days ago. And so we're doing this the other day because we're just a little bit ahead in that class. And then he just keeps on going. And I'm like, wow. He went past the numbers that I know. And I'm like, so and you're back in Germany, how, like what's the expectation? Where did you guys have to learn in school? Like this to 12 probably? Was that 10? Okay. He said they make him learn it till 20. So they know all their numbers till 20. Which is, I thought it was interesting. But anyway, okay. If you see these numbers, they need to stick out to you like neon lights. They're special numbers, okay? So now let's actually get to the part of difference of perfect squares, okay? They look like this. So this is called a binomial, okay? Because it has 2 parts, 2 terms. We call those parts terms. One part, one part. Parts are always separated by plus or minus signs. So that's how we tell if it's a 2-part, 1-part, 3-part. Okay, so it's a 2-part. And you just have to ask yourself these questions. If you answer yes to all the answers, then it's a really easy problem, okay? And that question is this. Is this a perfect square? So I'm gonna ask that differently. How do we get x squared? What times what? X times x. Are those 2 x's the same thing? Yeah, so it's a perfect square, because that's what a perfect square is when you multiply it by itself, right? So, a perfect square, okay? Is 25 a perfect square?
Yeah.
Yes. And then the other question that's different is it minus? Okay, notice the title does not say sum of perfect. It only works if it's minus. Okay, only, this is really important, you understand it. So only if it's minus, okay, which this one is. So if you answered yes, 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 then this is how you factor these problems, okay? Always, you just split the perfect squares back to their original. So x squared came from x times x, right? 5 or 25 came from 5 and 5. And always, guys, if you answered yes, 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 this will be plus, this will be minus. Or vice versa. That one will be minus, this will, they'll be opposite signs as well. Okay? I know you've seen them before, but just pretending, I always teach you like as if you didn't know. So let's try one of those. Let me throw a little curveball at you, but it's still the same concept, okay? Nothing new. Just putting 2 and 2 together. Try this one. Ask yourself those questions. Is this a perfect square? Is this a perfect square? Is this a perfect square? Is it subtraction? And if you answer yes to everything, then that's how you do it. It'll work like that 100% of the time. It's a no judgment zone, so if you don't know your perfect squares, okay, like I told you yesterday, it's not our fault, it is what it is. Have that list right there in front of you. That's why we took time to write that list up. That way you can just quickly look at the list and see, is that number on there, right? Okay, so is 36 a perfect square? Yes. Is x squared? I already handled it. Is 25 a perfect square? Is y squared a perfect square? Yes, I want you to be confident about that, because how did y squared come about? Y times y, so that's y. And it's also minus, so notice it's yes, 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 yes. Okay, so it's gonna be 1 parentheses, 2 parentheses, 1 will be plus, 1 will be minus, okay? One part that might trick you up is the location of where these are coming from, and you just follow the same order. So for example, 36 is in the front, that means the 2 6s will be in the front. That's how you pick the order, okay? The x's are in the front, so they'll be in the front as well. The 25 and the y are on the back side of the binomial, so they'll be on the back side of both of these. So 5y, 5. That's the order, because that's what I could tell you guys were kind of struggling on the order. A common mistake that happens early on is students will put, like they see x squared, they'll put x squared, x squared. But that's incorrect, because x squared times x squared is x to the 4th. Okay, so remember, what's really happening here is I could multiply these back through if I wanted to. And that's how that 36 comes to be, right? Is that good, guys? Make sense? How many of you had that answer before I put on there? I don't, okay, that's pretty good. Okay, let's try another one. 3. Let's do 49. I saw about 50% of the class, so I want to make 80 before we move on. So no tricks on this one. This is like just like the same one. This is like the last one, same flavor. Both. If they were flavors of ice cream, both of them were chocolate. most of you are finishing up. Okay, so here we go. Right, you would ask yourself perfect square, perfect square, perfect square, perfect square, minus. Right, so yes. So 49 comes from what number? 7. No, that 7 came out weird. X plus minus. 64 came from 8, and then Z. My Z's, by the way, always look like that because my Z's, my 2's look very similar. That way you know, you can tell them apart. Anyways, there's your answer. How many hands, please, this time? How many you got it right? Okay, a lot better. It's like almost 100%. Good. Okay. All right, guys, try this one. You know, they have the Rock Award here at Camp Rock, like if you're doing a really good job about something. Do they have like the Mean Award? Is there anything like that here? Then I would win it right now. It's just, I just did something mean to you, right? Why? Right? Because you have, a lot of you have x plus 2, x minus 2. But remember, you can't do that, okay? If this is plus. Okay. But once you did it one time, it won't happen to you again. So hopefully you will learn from that. Okay, so this does not factor, so we just put not factor. Can't factor. Not factor, that's not a full sentence, but you can't factor would be better. Okay, you can't factor it. And I'll tell you real quick why. When you do like a plus and a minus 2, for example, okay? If I'm gonna multiply this super fast, okay, but you get 2x minus 4, and then you get x squared plus 2x. But this is the part I want you to see. When you add it, you get x squared plus 4x minus 4. So you end up with the middle term here. Okay, notice that does not have that middle term. So you can't, it doesn't work that way. Sorry. It cancels that middle term because one's positive, one's negative. But notice how you get x squared minus 4 instead of plus 4. Okay, and that's why it doesn't work. You get a middle term if you're like, well, what if we make it a plus 2 and a plus 2, or a minus 2 and a minus 2? And that will give you that positive 4, but then you're gonna end up with this middle term. Okay, so it doesn't work. So it only works with minus. Is that okay, guys? I just really wanted to bring that home to you. Okay, only with minus. Okay, number 5. Let's say you had negative 16 plus x squared. Now, I just did that whole spill, and now I showed you a plus again in the middle, and so you might say, oh, you just told me you can't factor that, right? Yes, but, okay, stay with me, okay? What's the answer to that? Okay, good, I'm glad. So again, it's a reality, okay, it's a reality, right? We're not very good with that instruction numbers. You're not the first one. So since I've been teaching, that's the case, okay? I wish we had the time. I would spend a whole period teaching you to be good, but we don't have time, so I'm gonna give you a really quick lesson on this. So time out on the difference of squares, and let's do this, okay? What I was about to ask you is, what's the answer to this also? But before I do that, okay, I wanna teach you something, how to add and subtract positive and negative numbers, and it always works. We all like money, right? All of us like money, so just think of money. Now, before I do that, the sign to the left of a number always comes with that number. So this is a positive 2, that's a negative 3. That's a positive 2, that's a negative 3. The sign to the left, you bubble it together, okay? Now, think of positive as I have that money. You have it in your wallet, in your purse, or you have it in your pocket. So this scenario, I have $2 in my wallet. This scenario, negative, means I owe that money. Okay, so you have to really apply it to real life. If you don't really apply it, it won't make sense. So I have to like think, if I have $2 here and I owe her $3, what can happen there, right? I can pay her $2, because that's all I have is $2. But I owe her 3. So how much am I still gonna owe her? 1, right? But it's still owed. It's still negative. Okay? That's the same scenario at the bottom. Look, I have $2, but I owe her 3. So I can pay her 2, but I'm still gonna owe her 1. Okay, so in both scenarios is the same answer. Okay, so just think of money, guys, and then you can do those problems. So, but anyway, so parentheses, close parentheses on that. Let's go back to this. Notice it's the same answer, okay, regardless of the order. So what I'm trying to show you here is this goes together, this goes together. So can I switch the order? And the answer is yes. Just like I could switch these, I can switch those. So I can do x squared minus 16. Now can I factor this with difference of squares? Absolutely. Okay. Perfect square, minus in the middle. So go ahead and do that real quick. Easy peasy, right? But the important part about this problem is that you understand you can move them as long as you move the sign. Okay? All right, number 6. So notice we're learning something with all of these. Okay? Almost done. This one and one more. What if I had x to the 4th minus 16? It's very similar to the one we just did. Okay? So let's do it together. Is x4 a perfect square? Is there something I can multiply by itself to get x to the 4th? Yeah, what would that be? x2, right? X squared, right? So is 16 a perfect square? Yes. And it's also minus. So notice I answered yes, yes, yes. So we can do this. Okay, so we make our 2 parentheses. One is plus, one is minus. This came from x squared. This came from x squared. 16 came from 4s. So 4 times 4. Okay, now typically students would stop right here. Okay? But that's the difference about this problem. Notice, you can discard this one right away, because it's plus. Remember, it can't be plus. But this one's still minus. Okay? Is this a perfect square?
Yes.
Yes. Is 4 a perfect square?
Yeah.
Yeah. So you go further on this one. Okay, so I have this, and then this one breaks down to x plus 2, x minus. Okay, so the moral of that one is if you can go further, you go further. You go as far down as you can. Question, guys. Does that make sense? Yeah. Question, anybody? Okay, last one, okay, number 7. This one is, put a little star on it. This one has everything put together. So if you get this one, you got it done. Let's do 2 x to the 4th minus 162. Now you take the same approach as earlier, okay, and you ask yourself, is this a perfect square? Is this a perfect square? Okay, so my first question is 2 a perfect square? Okay, all day people have been telling me yes, but let's think about it. One number times itself is 2. Right, because what's 1 times 1? And then if you do the next number, 2 times 2 is already 4. So we jumped over it. Okay, so it seems like it is, but it's not. So you don't have to break your head there, like it's not one of those problems yet. Okay. So this mixes up what we were doing the other day with this. Okay, so is there anything we can reduce this by, a GCF, something we could take out of both terms? 2, right? They're both even numbers, right? So even numbers are divisible by 2. Okay. So we can divide a 2 from both of those. So I put the 2 outside. Now I have x to the 4th, and 162 divided by 2 is 81. So So I took a GCF out first, and now you ask yourself, what about this? Can I do difference of squares with that?
Yeah.
Yeah, and so you keep on going. Okay, so let me go ahead and let you finish this problem. You go as far as you can, okay? As far as you can. Okay, so let's see where you guys are at. So we have a 2, right, that we took out. This breaks down to x squared plus 8, x squared minus 8, not 8. What number, guys?
9.
9. 9 times 9 is 81. Okay. Can I go further?
Yeah.
Yes, right, so we can, this is what your eyes should be drawn to. Always the minus one, not the plus one. So 2, this one stays, but this one breaks down to x plus 3, x minus 3. And there, you're done. Okay, that's all there's to it. Okay. Questions, guys? No? Okay, so that wraps up those notes, okay?